Hello, this is Professor Michael Fournet, and I want to welcome you to the course Intro to Microeconomics. I'm going to be doing over the next few weeks a series of lectures on each chapter that we have included in this course. And the objective of the lectures is not to be a replacement for studying your textbook, but the lectures are to supplement the text and hopefully to give you more insight. I will, for some chapters, I will be making handouts available, and you will need those handouts at your disposal as we go through the lectures. There will also be some concepts that I will mention during the lecture that I'm assuming that you have read and studied in preparation for the video lectures that I'm going to do. This week we will start to take a look at some basic concepts which are discussed in chapter 1, which is entitled Limits, Alternatives, and Choice. And in this chapter there are some fundamental economic concepts that serve as a theme for all types of economic inquiry. So whether you're studying micro, as we will in this class, or you're studying macroeconomics, these basic concepts kind of serve as foundational issues. First thing we will look at is we need to make a distinction between what is microeconomics versus what is macroeconomics. This class, microeconomics, we focus on individual economic units. For example, in this class we'll look at the behavior of a consumer. We'll also look at the behavior of a particular type of business. So the focus here is on individual economic behavior. Contrast that with macroeconomics. Macroeconomics focuses on group behavior. So in a macro class, for example, you would study the behavior of all consumers in a particular country, or all business organizations within a country, all levels of government within a particular country. So macro has kind of a group focus. You can kind of think of micro as being kind of a subset of macro, because if micro consists of individual units and macro is group units, you can take individual units and group them together to get macro. Or by the same token, you could take a group of units, break them apart, and the individual components will represent micro. So micro and macro are two branches of economic inquiry, and we go down the very interesting branch of microeconomics. Now, when you're studying economics, whether it's micro or macro, there are some basic core concepts that kind of govern the nature of your inquiry. And so a good place for us to start is to have a kind of a working definition of economics. And economics can be defined as the study of how a society allocates scarce resources amongst unlimited wants. So it looks at how resources, which are by definition limited, how they're used to assess wants, which are basically unlimited. Now, the human wants, that refers to the wants for goods and services. And so I will periodically use the term output. And so when I say output, I'm really referring to the production of goods and services. That's what we want. We want stuff. And so the goods and services that we want are simply resources that have been transformed. And so sometimes in lieu of saying resources, I'll say inputs, or occasionally I will say factors of production. So those three terms are really kind of synonyms: inputs, resources, factors of production. So we take inputs and we try to transform them into output. Now, the reality is you can't take something that's limited or scarce and satisfy something that's basically unlimited, like wants. And so where economics shows up, it helps us to make good choices. So economics gives us guidance in terms of how to make a good choice. And a good choice will be one that takes inputs and doesn't squander them in the production process. So good choices take inputs and try to transform them into the most output. I will say more on choices in a second. Now, once you start making choices, that by definition means that once I choose, it means that once I commit to doing something, it also means I'm decommitting to doing something else. Like if I decide to take a step forward, that also means that I can't simultaneously be standing still. So opportunity cost looks at what you give up when you make a choice. And we have to make choices because of the limitation on resources. Because we don't have enough inputs, we can't have everything we want, and so we have to make choices. And economics helps us to make good choices. Opportunity cost simply looks at what we give up when we make a choice. Now, going back to choices, there is some criterion that we use to identify good choices, and that criterion is called efficiency. So one of the fundamental concepts that will run through this course is the concept of efficiency. And efficiency, I can define it as simply the ratio of outputs to inputs. So we take inputs, try to transform them into output, and how effective we are at doing that says a lot about our efficiency. Now, ideally, what we want to do is we want to take the inputs we use and perfectly transform them into output. And so if we can do that, if we can take the inputs we're using and perfectly transform them into output to where no inputs are wasted, that's considered maximum efficiency. So maximum efficiency for us is where the inputs we're using are perfectly transformed into output. For example, if I take 5 inputs and I run them through a production process, and those 5 inputs get perfectly transformed into 5 usable units of output, then nothing is wasted. And so under those conditions, we have attained maximum efficiency. I'm going to identify that case as what I call the best choice, because the best choice would in that case result in no waste. Looking at the definition of efficiency, it's a fraction. It has a numerator and it has a denominator. And so if the output we're getting equals the inputs we've used, then I'm going to assign E a value of 1. So we're going to put a maximum cap on efficiency of 1, where we take inputs, perfectly transform them into output. Now there are other possibilities as well. Sometimes we will take inputs and use them and not get the maximum output, and that's going to involve some waste. For example, if I take 5 inputs, transform them into only 3 units of output, then 2 of those input units got wasted. And so under those conditions, the value of E will be less than 1 but greater than 0, because the inputs we used were not fully transformed into the maximum output. And so some inefficiency results, I'm going to refer to those cases as mixed choices, as a mixed choice. The absolute most horrendous case is where we take some inputs, some positive amount of inputs, and run them through a production process and get no output. So it's like if I take 5 inputs, run them through a production process, and nothing comes out in terms of goods and services, then all those inputs got wasted, and that's a sign of total inefficiency, or the absolute worst choice. So when it comes to making choices, we want choices that result in the minimization of waste, because wasting scarce resources translates into goods and services that will never be produced. Alright, an application of these concepts shows up first in a concept called the production possibilities curve. So the production possibilities curve will embody the issue of scarcity, choice, and opportunity cost. And so it's our first kind of analytical model for the course, and I want to introduce it at this point. And so in terms of definition, the production possibilities curve can be defined as a curve that shows the maximum amount of 2 goods that can be produced from a given amount of resources. So right from the definition, I get a sense of scarcity, where it refers to given amount of resources. So the given amount of resources is telling me that there is some resource limitation. Choice shows up in the sense that the production possibility curve assumes that only two goods are produced, and so if you only have production of two goods, you have to choose which combination of those two goods you desire. In terms of opportunity cost, once we commit to one combination of the two goods, that means simultaneously that we are decommitting to other possible combinations. So we can see, as we will demonstrate, that the production possibilities curve does in fact embody the issue of scarcity, choice, and opportunity cost. Now before you study the production possibilities curve, you have to recognize that this model is built on something called an assumption, and assumptions are simply statements designed to simplify reality. And so the production possibilities curve is built on the assumption that if any combination of goods is produced that reside on the curve itself or inside the curve, those combinations are produced using all the resources. So what that says, in effect, when you look at the production possibilities curve, if you see combinations of goods that reside on the curve itself or combinations that are inside of the curve, those combinations, if chosen, will use all of society's resources. And so what the assumption is doing is giving those combinations on the curve and inside the curve the same input denominator. Because remember, as we're striving for efficiency, we're looking at the output we're getting from the inputs we're using. And so to investigate the production possibilities curve, let's take a look at one graphically. And a good illustration of that, I can pull one up here in a second. To illustrate the production possibilities curve, let's introduce one. Alright, so here I have created a simple illustration of a production possibilities curve, and let's say this curve applies to some small economy. Alright, and you notice I have points identified as point A, kind of corresponding to the origin there. I have a point in the middle of the framework that I call point B, and then I have a point way beyond the curve itself that I'll call point C. So those represent some of the different production possibilities that are involved. Notice we got two goods. One good I'll call good A, and the other good I'll call good B. And so we want to look at different combinations of these goods to see if in fact we can find combinations that are efficient. Alright, a couple kind of fundamental things. The curve itself, this kind of purplish line curve, is reflecting graphically the degree of scarcity. So the magnitude of the curve is depicting how many resources are available to this small economy. If I had drawn the curve smaller, make it like maybe something like that, then that would imply that scarcity is more of a problem because the production possibilities curve would be smaller. Of course, if I had drawn the curve to be bigger, have it more bowed out, that would imply that more resources are available and hence scarcity is less of a problem. So the position of the curve is depicting scarcity graphically. Think of the curve as like a mound, representing a mound of resources that we can tap into to produce different combinations of these two goods. Right? So the curve is depicting scarcity. The alphabet, point A, point B, point C, for example, they represent different choices, different combinations of these two goods. For example, point B would represent a certain amount of good B, and also it would represent a certain amount of good A. So point B would represent a certain amount of good A and a specific amount of good B. Now, there are many other possibilities, and what we want to find is which possibilities are the most efficient. And so, with a kind of a simple rule of thumb for identifying good choices, where output equals input, is any combination that falls on the curve. So any combination that falls on this curve is going to be an output combination on the input curve. And so when output equals input, there is no waste. So any combination on the curve itself is going to be considered a good choice because there's no waste of resources. Inside the curve, this point B is considered a mixed case because it involves some waste. That is, given the assumption that every point on the curve and every point inside the curve, like B, if produced, would be produced using all the resources. So if I produce a point on the curve, I use all the resources. If I produce a point inside the curve, like B, I still would use all the resources in that choice. And so clearly, if I'm using all the resources for point combination B, but getting less output compared to points on the curve, then point B would be considered inefficient. So in general, any combination inside this curve, if produced, is going to result in some waste. It's going to be some degree inefficient, or the E value would be less than 1 but greater than 0. Now at the origin, we have point A. There, again, to devote activities to combination A, you use all the resources, but point A corresponds to getting no output. So you have no output for having used all the resources. So at point A, it would represent a point of complete inefficiency, total waste. So point A, we want to avoid that type of production possibility because it means we will waste all the resources. So points on the curve, E is 1. Points inside the curve, such as point B, E is less than 1 but greater than 0. Points at the origin, such as A, E would be equal to 0, A representing a total waste of resources. The combination C that's out in the production possibility space is a combination that's currently beyond our production possibilities. The curve itself is depicting the maximum that we can produce. So any combination to the right of the curve, in any direction, any combination to the right of the curve is going to be currently unattainable because we simply don't have the resource to produce that much output. Now if I look at, so we can generalize and say it this way: combinations to the right of the curve like point C are currently unattainable. Combinations on the curve are completely efficient. Combinations inside the curve involve some waste, so they are to some degree inefficient. And a combination at the origin would be a total waste of resources because we get no output for having used all the inputs. Now the curve I've drawn here is kind of stationary, but the production possibilities curve can also shift, for example, and as I show in the next exhibit, the production possibilities curve, if it shifts from its original position, say it expands out to the right, so it goes from PPC, the first one, over to PPC2. When the production possibilities curve expands, that means that we can now produce more combinations of good A and good B. In other words, using our mound of resources analogy, if we have more resources, the curve will become thicker. It starts to expand. And when you have more resources, more inputs, that allow you to produce more output. Now there are a couple of things I will mention that will make the production possibilities curve expand. One kind of obvious one is that if we find additional resources, we find more resources and add them to the current amount of resources we have, the production possibilities curve is going to start to get thicker. It's going to start to expand. More inputs would translate to more output. Another way the production possibilities curve can expand is that we could have improvements in technology. Technology allows us to get more with less. So what technology in effect does, it takes the production possibilities curve and kind of stretches it in all directions, and in stretching it, we're able to squeeze out more output as a result. Alright, so that's the basic workings of the production possibilities curve. The last issue we need to look at in chapter 1, this basic chapter, is we need to look at the distinction between what are called normative economic statements versus positive economic statements. Normative economic statements, as I've indicated here, they incorporate value judgments and opinions. So one of the ways to kind of always identify a normative statement is you'll see lead-in phrases like "I believe" or I think this is true. Those are kind of clues as to dealing with kind of opinionated statements about economic activity. They're often characterized as what ought to be. Again, what ought to be is really based in opinion, and so normative statements have that distinctive feature. As an example, if I say I believe gas prices should be subsidized by the federal government, that's my opinion, and that's a normative statement. So normative statements have value judgments attached to them. In contrast to normative statements, you have also positive economic statements. And positive economic statements are these statements based on factual things. Like if I conduct some economic research and based on my findings say, okay, based on these facts, here's the relationship. Those type of statements are called positive. And they're sometimes referred to as the what is statement. The what is suggesting that those statements have gone through some sort of economic grinder to make sure that we can make connection between the concepts we're discussing. So positive statements focus on what is. They are rooted kind of in causation, cause and effect. They tend to be devoid of value judgments to a significant degree, and they tend to be more driven by empirical findings. An example, federal tax is a tax component of retail gas price. This is true. If you look at the structure of a retail gas price, one component built into the price is a tax component, right? So distinguishing between normative economic statements versus positive economic statements. For normative, look out for opinions, I believe, I think, I suspect. Those are clues that you're dealing with normative statements. Positive statements are rooted more so in factual results. Okay, so that concludes this lecture for the basic concepts in Chapter 1. If you have questions about the lecture, feel free to send me a message. But again, please look over the chapters, study the material, do the homework, and I think it'll reinforce. And you feel free to look at these lectures as many times as you like. Hopefully that they can help you and serve as a guide to being successful in the course. Until next week, take care.